Alright, so here's the assembled Lewis. I haven't actually done a video yet analyzing the Saris Z linkage yet, so I already talked about the swing for the XY, so mostly I'm going to be focusing now on what is the Z-axis. So you can see it uses a Saris linkage, and it goes up and down. It's straightforward. So things that need to be improved on this guy. Well, first off, we have this right here is in there, and that's where most of the rotation comes from, is that because there's not another one going from here to there to help prevent it from rotating, so it's a little bit more free than it should be. You can see that this down here doesn't wobble nearly as much. So what else? Doing that would mean these screws need to be slightly larger, but I don't think that's a big deal because the screw count is already so low. If anything, it might actually be the same length as the guy that goes from here and attaches to the bottom of the or the front plate of the stepper motor. So in general, we're going to add a fourth link. I'd like to try to make these parts symmetric, so you see how this guy has two, or like a fork style, right? So it can get pinned in, and then this guy has one link. I'd like to do alternating, so I can use the same OpenSCAD code. It's more of a lazy thing. This, instead of being a circle, could also be a square. And we're obviously going to need feet because it doesn't stand up on its own. What's cool about the feet is, since if we put them at an angle here, we could mount electronics in this space and stuff like that. Next thing, so the alright, we'll go straight to the lead screw. I was originally going to use M6. I'm not too keen on that anymore. I think I want to use something like M3, M4. M5 would be nice because it's the same diameter as the shaft, but I don't have any on me right now, so I'll have to order that from McMaster for testing, so I'm probably going to use M4 on the prototype. The connection between top and bottom, you can see I just use these two pieces, and it sways a little bit. So I think I want to try to open this up, so not make a full plate, but something a little bit more open. But again, keep... Alright, I'm sorry, I take that back. I can't make it fully round because there's this link here. Yes, this link going to the lead screw. So I kind of want to add some thickness in that direction, going that way. Sorry, it's kind of hard to demonstrate on this thing. So that's basically it. So I want to try to eliminate that sway, and then sway in the Saris. So I'm not sure how much I can constrain the Saris. I might end up wanting to put a bearing at the top, or just this outer diameter here, or sorry, this, what would be the outer diameter bearing, just match that circle to the outer diameter of the bearing, pop a bearing in there. It'd be kind of convenient. So that's mostly it. What else? I mean, just get the feet on there and we should be good. I sourced, so again, this is kind of an update. The other video I made almost a week ago. So I was able to source 400 steps per revolution NEMA 14s, which I'm pretty excited about. So again, we'll be able to keep the same profile, or the same size, the compactness. They're actually even shorter, so they'll be lighter, and when we flip the motor around, it's not going to be touching the build bed. Then also the nozzle can be shorter, I hope. So that's mostly it. Just a quick update. And this will all be posted on the blog as well. Thank you.